Okay, today we're talking about ellipses. Again, if you take a cone and kind of slant a plane through that cone, the shape formed by that cross section is an ellipse. Kind of looks like an oval, but we call it ellipse. It's a set of all points in the plane, the sum of whose distances from two focus points, F1 and F2, is constant. So I'm going to try and tell you what that looks like. So these focus points, F1 and F2, are focus points. And this is just a point that will be a point on the ellipse here. So think of this almost like if that dotted line is kind of like a big long piece of yarn or string. You're kind of using your pencil to hold it taut there, and you're kind of moving it around. And as you move it around, you're leaving a trail behind. And each one of those points, as you move it, see that the string is the same length no matter what. So the distance, the sum of the distance from that point to F2 and that point at F1 is constant. And so if we keep moving that point, it kind of skips around every once in a while. Well, it did some funny things there. So shouldn't have done that. I guess I was dragging it funny. Wow, that's really weird. So it shouldn't be doing that, but oh well. It should form a perfect ellipse. I think you got the idea of it. I think it got confused there for a minute. But it will form an ellipse if you do that. So that's the definition of ellipse. So these formulas, again, I want you to have your formula sheet and use this on the test for me. So this is the formula for an ellipse. Again, we're starting with the basics here. We're starting with, we'll move these after we can learn how to do them. So this is with the center, instead of the vertex, the center is at the origin or at 0, 0. So you can see the center is definitely at 0, 0 there. This point right here is focus. We'll just call it F1 for the first focus, and we'll call this the second focus, so F2. This is the major axis. So the major axis is the longer axis. You can probably tell this is a horizontal ellipse because it's a little longer than it is tall, a little wider. So that total distance from this point, which is the vertex, and this other point, which is the vertex. So these points at the end of the major longer axis are called vertice points. And this point right here is called a covertice. And same thing with this point down here. This would be a covertice down there. So that's the shorter, that's called, so this is the major axis. And the distance from, from here to here, which is a much shorter distance, is the minor axis. So that's the minor axis. So that's the picture, and of course, like it kind of helps to see some of these different relationships. So from here to here, from the center to the focus point is a distance of c. You can see that's the point c, 0. And then from the distance from A, or the vertex, to there is called A. So that's a little long. A is a little longer than C is. Again, C is the distance from the focus to the center. And this distance from the vertex to the center is called A. And A is always bigger than C. In fact, A is always bigger than B. So A is always this value on the major axis. Half the major axis is A there. The minor axis, this might make sense. This distance here is B, and this distance from here to here is B. So that's the B is always smaller because the major axis is longer. So the minor axis would be smaller. So half the major axis is more than half the minor axis there. So A is always the biggest number. A is always bigger than B, and they're always positive. We never have an A value or B value that's negative. That's what this first statement is saying. It's saying this is not quite the Pythagorean theorem, but it has a similar relationship if A squared is the hypotenuse. And so it's saying that A is the longest of those three. And if you add up the squares of B squared plus C squared, you would get A squared there. The vertices are located, again, this is when the center is at 0, 0. These formulas are subject to change. But I'm going to write them both at the same time. So this would be plus or minus A, 0. So A, 0 and negative A, 0. You can see that's where those vertices are located. The foci are located at the, let's see, this is going to be plus or minus c, comma 0. The major axis, you can probably tell, is it from the vertex to the center is A, from the center to the vertex is A, so this is 2A. And the distance of the minor axis, the green line there, is B plus B, or 2B, so 2B or not to B. And again, this formula here, we'll learn more about this in a minute, the formula, but definitely write down that formula for horizontal ellipse as well. Go ahead and just get all the formulas out of the way. Let's do the vertical ellipse formulas. So in a similar way, this distance is C. Guess what? A is always longer than C for an ellipse. So because what's going to happen here is the focus points are both on the major longer axis here. The minor axis in this case is the shorter axis, which is the horizontal one. And so again, this is a focus point right there on the major axis, the focus point on the major axis. Interesting enough, if both focus points were in the center, it would be called a circle, which technically is a type of ellipse. The formulas are the same, except you may notice, a squared, b squared, now it's b squared, a squared. So the bigger number now is underneath y, the smaller number is underneath x when it's vertical. These formulas are exactly the same, they didn't change. Vertices will change for sure. So this is going to be 0, comma, plus or minus c. So again, kind of go up c and down c to get to those focus points. Oh, sorry. Those are the focus points. I was doing the focus points first. The vertices would be 0, comma, plus or minus a. And the major axis still is 2a, even though now it's up and down, it's still the same formula, and the minor axis is 2b. Okay, finally a problem. We're going to have to figure out what's going on here. And one of the things I don't like, if you notice on the last two, both formulas, they're both set equal to 1. That one's equal to 1. This one's equal to 1. Well, what's different is this was not equal to 1. So I think we need to do something to every term in order for that to be 1 on the right-hand side. So to do that, I would definitely divide by whatever's over there, which is 36. So we get equals 1. Right away, it's starting to look like an ellipse equation. I think that goes in there. So 4 divided by 36 is 1/9, I believe. So that's 1 over 9. Plus, I think 9 and 36 cancel. That's 1/4. So that's y squared over 4. Now we have our equation, right? So let's try to do this without the formulas, and then we'll use the formulas as we need to. So the way I think about this is our bigger number, our a squared is underneath x in this case. Our smaller number, I'm calling it b squared, is underneath y. So because the bigger number is underneath x, I mean, you could look back at the formulas, you can see a squared is definitely a horizontal. It's definitely wider than it is tall. And really, you want to go a distance of a. So we start at the center. You want to go distance of a in each direction. So I'm going to go a squared is 9. So I'm going to go 3 units to the right and 3 units to the left to make my points. So those are the vertices actually, right? That's going to set up that the distance between those would be the major axis. And then the vertical is always underneath y. I don't remember the formulas. Just remember, like underneath x, horizontal change. Underneath y, vertical change. So square root of 4 is 2. So I'm going to go up 2 and down 2 and make my point. And now I can draw my beautiful ellipse, best you can. And somewhere on this major longer axis will be the focus point. So that's the major axis. So somewhere on there will be our focus point. So you could use a formula, but we really need that formula, this one, right? You need c squared equals a squared minus b squared. So let's see if we can do this. Let's get c squared equals a squared minus b squared. So c squared equals, well, a squared is 9, minus b squared is 4, so c squared equals 5. So c equals square root of 5, because we took the square root of both sides. Don't forget plus or minus, except with a, b, and c, we're talking about positive values. They're distances here as far as ellipses are concerned. So, and that's approximately equal to, I don't know, more than 2 point something. So because 2 squared is 4, 3 squared, so probably 2.2 or something. So just a little bit more than 2. That's one focus point. A little bit less than 2. That's another focus point. So those are our 2 focus points. They're on the major axis, a distance away. Again, this distance on the major axis, this distance is c. Right, from here to here is c. And we said c is 2 point something here, 2.2-ish. So I went 2.2 in each direction. The actual ordered pairs, this is where I really think it helps because I want to see these ordered pairs. I really think the formulas help. So in this case, the focus is plus or minus c comma 0, right? So I think that point would be, the focus point would be plus or minus c is square root of 5 comma 0. So you see I'm just plugging in square root of 5 because that's my c value, and I plugged it in, and now I have those exact ordered pairs, which is really what I want. The vertices are easy to get. You don't necessarily need formulas because it looks like they're at plus or minus 3 comma 0. Length of the major axis is pretty easy to spot. That's 3 plus 3 is 6, or 2 times 2 times a, which is 3, so 2 times 3 is 6. The length of the major axis is 2 times b, or 2 times 2, which is 4. You can just count it out to 1, 2, 3, 4. It just is a 4. Oh, I forgot to mention eccentricity. So I don't think I put eccentricity on either one, did I? So eccentricity is c, the ratio of c over a. I thought I had a slide on that. Maybe I don't. Maybe it's my other file. So eccentricity for this one, let's go back to it. Okay, so just a ratio of c over a. So c is square root of 5 over a, which was 3, I believe. And you just use your calculator to get the eccentricity. And so just a measure of how squished something is kind of what eccentricity is. The biggest it could be, since it's a over c, or c over a, because it's really c, again, c over a. So a is always bigger than c, so it can't be, unless c is really big. So if it was like really squished, it would be close to 1. If it's not very squished at all, I think it'd be close to 0. Of course, it could be negative or positive. So it could be close to 1 or negative 1, or close to 0 in those cases. Find an equation for the ellipse. So this one, so they didn't give us the, oh wow, okay, so let's try to draw this because that really helps, I think, to kind of think things through a little. Okay, so we're going to draw, the vertices are going to be at 0, 5. 1, 2, 3, 4, 5. That's a vertice. And 1, 2, 3, 4, 5. That's also a vertice. The focus points are at 0, 3 and 0, negative 3. Okay, so I know, like if you think back to what you know, I think maybe you're getting this idea, but the distance from here to here is called c. Well, c in this case would equal 3. Distance from here to here is called a, and that distance is 5. So we know a is 5 and c is 3. So let's use our formula. C squared, what was our formula again? C squared equals a squared minus b squared. C squared equals a squared minus b squared. So c squared is 9 equals a squared is 25 minus b squared. So I'm going to solve that. So we get b squared equals 25 minus 9, which is 16. Take square root of both sides. Don't forget plus or minus up. We don't need that because these are distances. So b equals 4. So what that means is really need to know how wide this ellipse is. And now I know it's going to go 1, 2, 3, 4 units to the right, and 1, 2, 3, 4 units left. Those are the co-vertices now. So then you're just going to graph your graph. Looks something roughly like this. Goes through the co-vertices and the vertices. And again, that major axis is the longer axis there. And the focus points are both on the longer major axis. This one, let's try this one, see if this is any more difficult or about the same. So you want to divide by 25. You want to set that equal to 1. Ooh, this could be tough. Okay, let's see what happens. I really like this part. That's 1. I like this just fine, actually. That's pretty nice. Here's where I need a problem. So I have a problem. So x squared over 1 is 16/25. What do I do? So you really need a fraction down there. I don't know if this makes sense, but you need, instead of 16 over 25, it's going to be 25 over 16. Remember, dividing by a fraction is like multiplying by its reciprocal. So if I multiply the reciprocal, I would have 16/25. But it's best to think of that as your value down there. By the way, which one is bigger? Because it helps to know that, because is 25/16 bigger or 25 bigger? So to me, 25 is much bigger. That's just a little bit more than 1. So that's bigger. So that guy is your a squared, which means a is going to be 5. This guy is your b squared, which means b is the square root of that, which would be 5/4. So we can now kind of like graph our graph. So we've got the point in the center. That's the center point. Again, this is your a value. So a, in this case, underneath y squared is vertical. So I'm going to go up 5 and down 5. Underneath x is always horizontal, right? So I'm going to go to the right 5/4, which is a little bit more than 1, and to the left 5/4, which is a little bit more than 1, and go ahead and graph your graph. And we see, hopefully you see which one the major axis is. That number's bigger underneath, so you know it's this one. So somewhere on there, distance of c away will be my focus point. So you need the formula c squared equals a squared minus b squared. So a squared is 25 minus 25/16. That's not fun. Equals c squared. So we get, I might even just use my calculator for this. So what is 25? 25 minus, I think it was 25 over 16. I might have checked that. 375/16. Yeah. So c squared is 375 over 16. And then we're going to take the square root of both sides. So we get divided by 4 and the square root of 375, which is, I think, can be simplified because 25 goes into that, which is per square. So 25 goes into that 15 times. So I think this would be equal to 5 root 15 divided by 4 is my c value. Now you probably need to type that in your calculator to get it. So whatever, I'm just going to do this. So I'm going to square root, hopefully this works, square root of that value, 375 over 16, which is that, and then Control Enter gives you a decimal 4.8. So that's approximately 4.8. So I go 4.8 units up. Wow, way up there, close to 5. 4.8 units down, way down there. Those are my 2 focus points. Again, not a bad idea to use your actual, since this is our number here, those ordered pairs would be 0, comma, plus or minus square root of 15, 5 root 15 over 4. And then the vertices are easier. That would be 0, comma, plus or minus 5. You can just look at it and tell. Again, you could use your formulas if you need to. That's my focus point. The major axis distance is 6 plus 6, which is 12. Minor axis is 5 root 15 over 4 times 2, which is 5 root 15 over 2. Eccentricity is c over a, which c is that decimal 4.8-ish, divided by a, which is 12. Right. Sorry, c is actually 6, right? A is 6, I mean. Let's see, a is 5. 4.8 divided by 5, sorry. So let's just take that number we already, I just wrote 4.8 because I'm just going to divide this by 5. Whoops, divide by 5. We get 0.968. Wow, that's huge. So that's 0.968, very close to 1, which means this is a very squished ellipse for sure. Let's go backwards, see if we write the equation. First, decide if this is horizontal or vertical. You can probably see the x-axis is longer, so right away I'm like, okay, this is vertical. So we know our template is something like this. X squared plus y squared equals 1. Underneath x squared is going to be this a value here, which is going to be 5, so 5 squared, or 25. Here, this is 4, so b is 4, so this would be 4 squared. So I guess we get x squared over 25 plus y squared over 16, oh, that was sloppy up there, equals 1. So we got our equation pretty quick. Ellipses aren't too bad. I think you might actually start liking them. That's it.